Hello everyone and welcome back. In this video, I'm going to walk you through on how to set up a live synchronization process between an Oracle database and a PostgreSQL database. We will be utilizing Oracle Advanced Queue as well as a Python listener. This walkthrough is actually based on a real life situation that I faced at work. So we had to sync data from Oracle to Postgres, but one of the approaches was attempting to do a double write, which we eventually figured out wasn't too reliable, mostly to the fact that Oracle had many different entry points. In other words, we have multiple services that was writing to Oracle, and some of those services had different ways of writing to the table. So it wasn't incredibly reliable. Um, so some automated jobs as well as some app flows just differed. Um, so it was risky and hard to guarantee consistency if we tried writing to both databases directly. One of the more reliable approaches that we came across is to capture the changes directly inside of Oracle from the triggers, which gives us full visibility and control at the source of the truth. In other words, it was only coming from one trigger. Um, so effectively, once we captured it from the uh, once updates were being captured at the trigger level, we were doing a live sync from Oracle to Postgres directly. So in this video, I'll show you how we use Oracle's own advanced queuing system along with some Python glue code to stream those changes in real time into Postgres. So by the end of this walkthrough, we'll have a full working setup where any insert, update, or delete into a user table in Oracle gets captured and synced into a matching table in Postgres in real time. So this will include setting up Oracle Advanced Queue, defining triggers to capture those messages using queue, and then also writing a Python script that listens in on the Oracle Advanced Queue and applies the changes directly to Postgres. Let's talk about the agenda real quick. So the first part is we'll have some pre-existing code here already. So we'll do a review of what's already set up. We'll review Oracle database with users tables, sequence and before insert triggers for generating IDs on the Oracle side, and also reviewing Postgres database with the matching users table. The second part here will be the Oracle Advanced Queue setup. So we'll create the queue table, we'll create the queue, and then we'll create the after trigger for the Oracle users table. And then finally, we'll focus on the Python sync process. We'll define the bottles as well as the queries and read from Oracle AQ and sync directly to Postgres. And just a quick overview of how the architecture would look like, what this process would be. So on the left side, we have Oracle database. Again, any changes coming in will be captured at the trigger level. So at the trigger, we'll add some logic. After it's been inserted, it will actually add to Oracle Advanced Queue, and then we'll have the Python process running in the background that will monitor any action or any updates on the Oracle Advanced Queue. So if something gets added to the queue, LiveSync will know about it, and then it will process that record, dequeue it from Oracle Advanced Queue, and then add it to Postgres. So hence, that's the LiveSync process happening in real time. All right. So let's start by reviewing what's already in place before we write any new code or SQL. First, actually, before that, so right now I have two tools up. One is Oracle SQL Developer on the left side, which I use to view the Oracle database or connect to the Oracle database and then view what the contents are. Similarly, on the right side, we have pgadmin 4, which I use to connect and view contents of a PostgreSQL database. So now first, in our Oracle database, we have a users table with 3 columns: ID, name, and email. So let's also cover another portion here. So to handle ID generation, we've created a sequence called users sequence, and that's actually being utilized in a sequence called users BI that automatically assigns a new ID from the sequence if one is not provided. This way, Oracle owns the ID and we carry that same ID over to Postgres, ensuring consistency across systems. And on the Postgres side, we've also created a users table with the same structure, same column names, and same types where applicable. Except we're not auto-generating IDs here. That allows us to mirror the records exactly as they are in Oracle. So something to note as well before we continue further here is a live sync approach might not be the solution if you are relying on auto generation of primary keys. Now, why will that not work is because if you wanted to keep it consistent, there's only one primary ID. We can't copy that primary ID over to post. So for if a ID is being automatically generated in Oracle, we can't take that same ID over to Postgres because Postgres will generate their own ID. So if that's not an issue for you, where you don't really care about the primary key, you only care about the data, then this is still a working solution. But if you want exactly identical and consistent data, the ID generation has to be manual. So in Oracle's case, we're utilizing a sequence here and getting it from there, and then we're transferring that over to Postgres, where Postgres is also taking whatever it gets. That's just, again, as mentioned, that's just to ensure that we have consistent data here. And honestly, if we're doing a Postgres migration or a database migration, we want to have the same identical data in both. Otherwise, there could be some problems, and then that's could be another state that you have to maintain. So hopefully, primary keys are not being auto-generated here, and a live sync solution can still be the optimal solution. So now, with that being said, let's focus on setting up Oracle Advanced Queue. So next, let's set up Oracle Advanced Queues to start capturing changes for the users table. So first, we need to create a queue table. This is where Oracle will store the queue's metadata and messages. So like I have some of these codes already pre-generated. I've done it earlier. So I'll just be copying and pasting, but I'll provide some context as to what the code actually does. So let's go into, all right. So just to note that DBMS underscore AQADM is just a library, and this is a pack, or think of it as a package, and this is a function that within that package or library that we can execute. So the first step here, again, as mentioned, is to create the queue table. So queue table, we'll just take in a name. We'll call it user changes QT, queue table for short. And then it also needs a queue payload type. And then we're utilizing sysaqjms text message here as the payload type because we'll be sending JSON messages with each change. So once the queue table is actually created, we define the actual queue that will use it, and then we start the queue so that's ready to accept messages. Okay, so let's run this. Okay. So that's finished. Next step here, as mentioned, we'll be creating the queue and then actually starting it. So as for create queue, this will require the name, the name of the queue itself. Don't get that confused with the queue table. Queue table is what we just created earlier, and we're just mapping it to that table. So the queue maps to the queue table. And then now the next step is to actually start that queue. Again, this is just mapping to whatever we named the queue here. So let's rerun this. So now we have a queue running. And now comes the key part here. So the after trigger on the users table. Um, so this trigger fires on every insert, update, or delete, and then builds the JSON string representing the operation, and then enqueues it to the AQ. And then the idea here is this message will contain the operation type of either insert, update, and delete, as well as the relevant data. Um, so let's actually put that in motion here. Then I'll walk through again of what that means. So let's expand this window a bit. So again, we're creating a new trigger here, or user AQ NQ. And again, it's captured on after every insert, update, and delete. So don't focus too much on some of these data types here for under declare. Actually, maybe focus on JSON data here. This is what we'll need. But everything else was the payload. Well, yeah, there's three parts. So these are basically default standard template that we're utilizing for Oracle Advanced Queue. Payload, I think as mentioned earlier, we're utilizing a JMS text message here. It'll just be a JSON object. And then from here, we're just capturing each action. If inserting, we're formatting it, where we're capturing op, for short for operation, it's either insert, update, or delete, and then the relevant data. Here we're already formatting here the key information that we need. So in this case is data into an object of the IDs, the names, and the email. So the only key difference here between insert and update is for delete. The only thing we really need for delete will eventually just be the ID. We don't really need any other relevant data there. We just need the ID to identify, and then we'll send that over to we'll send the data over to Postgres for deletion. And then from here, we're setting up the payload. So basically, we're converting to whatever we generated here under JSON data, preparing it to a JSON object, and then sending that over to our. And then we're adding that. We're enqueuing the data into our AQ. Again, so a lot of this is pretty standard. I don't want to focus too much on explaining what these are, but it's provided by documentation. Basically, this is how we're going to focus on enqueuing the data. Now, okay, so the Oracle side at this point is ready. We'll switch over to Python. So we'll be building a small script that continuously reads from Oracle Advanced Queue and then applies the changes directly to Postgres. So we'll start by setting up our environment with a basic project structure. Again, I've generated this repo before the video was made, but no logic inside of them, except for config.py, which I will not open because that will contain your connection strings to Oracle EQ, Postgres, and Oracle. So I don't want to share credentials here, but everything else like models, Oracle EQ, Postgres database, run sync task, these will house some of our core logic here that will be responsible for dequeuing from Oracle Advanced Queue, processing the data that we get from there, and then doing an insert over to Postgres. So I guess without further ado, first things first here is we create a virtual environment here. So Python 3 -m venv dot venv. Okay, so we have it. Let's source it. In and activate it. Oh man, I messed it up. Okay. start it over. So activate. Okay, so now we're in our virtual environment here. And just to confirm, Python. Okay, we're running the virtual environment. So next step here is to update our requirements.txt. So we'll need 3. Okay, I put in the wrong one. We're parting it in the requirements.txt file, copying it over, and we need 3 things here. We need SQLAlchemy, Oracle DB to connect to our Oracle database, which we'll also utilize for Oracle Advanced Queue, as well as Scicop PG2 binary, and we'll be utilizing that to connect to our Postgres database instance. Okay, so from here, we'll run pip install -r requirements.txt. Here we go again. There we go. So that'll just install the packages that are defined in requirements.txt. And then next step, which I'm not going to show you, but open config.py and put any we'll define our Oracle DSN, Postgres connection DSN, Oracle Instant Client path, as well as Oracle AQ, the name of it. We'll just keep those private for now, but those are key. Okay. You know what? I'll keep it light because it might be easier to just visualize here. So we'll just assume this is the config file. What I'll need from there, or what we need to define from there, is Oracle DSN, Postgres DSN, Oracle Instant Client path. So all of these paths, by the way, I've already installed beforehand. So if you're going to be working with Oracle here, you'll need an instant client. Feel free to download that off Oracle's page. And then Oracle AQ. This one I can share. I mean, I think we called it user changes queue, right? User changes queue. Just the name of the queue that we created earlier. Now, as the path, this can be dependent on wherever you install it. Oracle DSN will just be your connection string to Oracle, and then Postgres will be your connection string to Postgres. So let's move this. So basically, those are the key variables that we need in config.py. All right. Now, the next thing here is we'll define the SQLAlchemy model. So under models, I'll copy and paste this so it's faster and simpler. So we'll need a few imports from SQLAlchemy. We'll invoke declarative base, then set up the model here, passing in base. And our table name here is users, right? And then the columns that we define, ID, name, and email, those all mirror with Postgres. And again, we keep the type pretty generic here. So ID is integer, name and email are both strings. Now the next step here is Oracle AQ logic. Again, I will just copy and paste core logic here. Yo, edit that part out. Thanks. So some few imports that we need here, and then the actual DQ logic from Oracle Advanced Q. We'll cover this one in a little more detail. Forgot one line. Okay. No, we don't really need this here. Okay, so as for the DQ logic, so even before that, we'll obviously need to create an engine here from SQLAlchemy, and that connects to our um, Oracle configuration here based on what we define in config. So as for the DQ logic, so we need a connection string here. We establish it. So yeah, we get the raw connection. From here, we need the object type. It's just part of connecting to the queue as well. So we need to define the object type here, which we defined earlier as sysaqjms text message. So we're getting the type from the connection string. And then when we're getting the raw connection to connect to the queue. We're passing in the name of the AQ. And then as for the payload type, we're passing in the type that we utilize. And then so what happens from here is we connect to the AQ. And then there's these are actually provided by, this method is actually provided by Oracle DB, which allows us to DQ from the queue itself. In this case, I'm just keep it simple here. We're utilizing DQ many with a limit of 1. So in this case, we're always DQing one record at a time from the queue. And then we're doing a check. If it returns greater than 0, that means something was DQ'd, and then we can process it. In this case, the payload, or we're taking, so just to make this clear as to why I'm putting out the 0 in, or the first index. All right, edit. All right, so let's go through this Oracle AQ logic line by line here. So we imported Oracle DB. That provides us with a few functions here that I'll refer to later. But the most important part here is from SQLAlchemy, we need to create the engine. And then we're utilizing Oracle DB as a driver, as well as connecting the Oracle DSN that we define in config. Now the DQ logic itself is, well, first we're getting a connection, a raw connection string. For us to connect to the queue from the connection, we also need to know the type that was utilized with the queue. So in this case, as mentioned earlier, we define sysaqjms text message. And then when we're connecting to the queue, we're passing in two things. We're passing in the name of the queue, and then the payload type, which is the type that we utilize for that queue. So from the queue itself, we have a function that allows us to call DQ many. In this case, it will return a list of whatever many is in the queue. But in this case, we're passing in a max of 1. So no matter how many records are in the queue, anytime we DQ, we're only getting 1 record at a time. And then we're checking the length of the list here. If it's greater than 0, obviously we got something from the queue, we want to process it. So again, at all times it's only 1, or so we're grabbing the first item in that list at all times, and then the payload. And then as for the payload, calling the text VC, which again, we stored all of this as a JSON object. So we're pulling everything from that payload, um, and then we commit. The commit's important here actually because that basically says that you want to save the changes. So once you dequeued from the Oracle Advanced Queue, save those changes complete from Oracle AQ side so that no one else is getting the same data. Um, and then here we're just parsing the JSON object that gets back and then returning that data. Okay, so now we went over the Oracle AQ DQ logic. The next one is the Postgres connection setup. So let's go to Postgres DB file. This is relatively short, but let's go over it. So the Postgres engine here, similar to what we talked about with AQ, is you got to create an engine to connect to it. And now we're passing in Postgres credentials. And then session maker, and then we're binding it to the engine. Okay, and now let's go for the sync logic itself. Sync task. And then from here, okay. So you might notice two different things here. So SQLAlchemy from SQLAlchemy directly, we're importing two functions here: update and delete. And those are relatively straightforward. The key difference here is we're importing directly from SQLAlchemy Postgres dialect. We're importing the insert. That I'll explain as we go through. But just something to note that these are the two key differences here based on the import. Now for the sync user, let's go through each. So basically, from the previous logic, Oracle AQ, right? Even going back actually, if we can, okay, so even going back in Oracle, the way we were storing the data is an object, JSON object, which had up and data, and then data contained all the information, right? So remembering that real quick, we go back to the code, and then in sync task. So for now, visually, just pretend that when we're calling sync user, we're already passing in the parse data of the JSON. So from that parse data, we have two keys. One's op, the operation, and then data. That actually contains the information that we need. And then we're conditional check here. We're just checking if op and data are valid. Otherwise, return it, do nothing. And then from here, we do conditional checks. If op is insert, we're inserting directly on Postgres, passing in the values of data. And just one minor conditional check as well is if there's a conflict, or in other words, if the Postgres ID already exists, and we're doing an insert, do nothing, because it's going to throw an error anyway, so we might as well protect our database. So if there's a conflict, it does nothing. And that's why we inserted that directly from Postgres dialect, because that's something provided directly by Postgres. Whereas update and delete, those are pretty standard. And let's talk about those two as well. So if the operation is update, we're just updating the user in Postgres, where it matches the ID, and then we're passing in the data provided to us. And then last, but definitely not least, is the delete. We're just matching whatever IDs are passed to us and then deleting that from Postgres. Then we execute the statement and then save the changes. Okay, and then let's talk about the main sync loop, the run sync. Pretty standard. A few imports here. BQ message and then sync user. Okay, so from here, again, we're checking, or if we first call DQ message, and let's review each code again so that we're all on the same page here. And DQ message is just DQing whatever record is in Oracle Advanced Queue and then returning the parsed object. Okay, and then we do a check. Which is indentation. Okay, there we go. Well, all of them are indented actually. Okay, let's fix that. So, okay, we just do a check. If there is a change, if there is a record that came back, that's when we pass that change over to sync user, again, as mentioned earlier, and then it does the processing, right? So now it just checks if it's insert, update, delete, and then passes it over to Postgres. Okay. And then similarly, we brushed over this, but this is a while true statement. So this process will run continuously, monitoring the queue so that any new records coming into Oracle, we're passing it over to Postgres real time. All right. So after all this, now let's see this in action. You'd be a little surprised if this works right off the bat, but let's see. All right, so I actually neglected to include one more important piece in Oracle AQ setup, and that's actually calling or initializing Oracle client on Oracle DB. And that function actually requires two things. The path of wherever your Oracle instant client is stored, as well as the configure. Configure is more of the where your wallet is stored, or the credentials of your wallet. I don't want to focus too much on Oracle setup here, because it's a case by case basis here, and we could end up debugging like how to set up Oracle, and that's not my main focus here. My main focus is live sync between Oracle to Postgres. So if you're having trouble setting up Oracle, maybe just do additional debugging on that, Googling. But again, this is like the core structure that we need here. So now we have this live sync process running in the background, and it's listening in on activities from AQ. So let's set this up, and then let's see if there's anything we need to address while we're running this. So let's go back to Oracle real quick. So the very first thing that we probably need to do is insert users, and then we need 3 columns: ID, name, email. We'll give it values. So I'll hard code this so that we don't use a sequence. So give it 1. Name is test, and then email test at test.com, whatever, right? And then make sure commit insert into users. Okay, so let's try to run this, and if this works fine, there should be no error on Python side. Let's see. Well, that's already an issue. Why are we not seeing anything? Well, first things first, the way we debug this is make sure, is there anything in the queue? So select all from user changes Qt. Let's see if there's anything in the queue table. So any records coming in or coming into Oracle Advanced Queue, we can view in the user changes Qt. Oh, and that's concerning. There's nothing in here. So did the trigger kick in? There's a question. Let's check. Huh, I thought we created the trigger earlier. So backspace a bit. Ah, okay. So I probably spent too much time explaining it that I forgot to run it. So execute this. Okay. Um, so it might be an issue that yeah. So that's already there. Okay, that's problematic. But for now, let's try adding a new one. Insert into. Probably should have deceived that syntax. It's fine. ID, name, email, values. We'll use the same one. Well, not the same ID, but we'll go with two. Same name, same email. Well, commit, run it. Okay, now let's go back to Python. Okay, so receive change, operation insert, and then the data exactly as so. This looks really good. That means if I go to Postgres, I should see those exact records, right? Let's see. Select all from users, and there you go. So under the hood, everything was captured. Just to be for sanity check, update users set name equals lowercase we'll just call it testing, where ID equals 2. We'll test all the operations. Let's commit, and then if we go back here, the name is changed to testing. Perfect. And then one more final thing is let's delete users where ID equals 2. And that should delete oh wait, okay, so one crucial thing with Oracle, if you've spent a lot of time working on it, is make sure you're committed. So we'll just commit that delete change so it saves in Oracle and eventually reads by the sync process, and then that should be gone here in Postgres. And there you go. So okay, so perfect. So we'll just do a quick recap here. So the sync process is now fully working. Just go by the code each real quick so that we're on the same page here. So we started with defining the models here. User, which should ideally be usable by both tables, but again, since we're only doing Postgres unidirectional sync from Oracle to Postgres, it's only being utilized by Postgres. Oracle AQ logic here is the core of syncing into Oracle Advanced Q. And again, this is the key part that I missed earlier, is we also have to make sure that we're initializing Oracle client, providing the instant client path, as well as the wallet, wherever you stored your wallet, if it's stored locally. And then we're connecting to Oracle AQ connections, or our Oracle, basically. We're connecting to the same Oracle instance, and then we dequeuing the message. As part of connecting to the queue, two things are important here, is providing the name as well as the type of whatever we're storing it as. And then it's just a matter of parsing the data that comes from Oracle Advanced Q. And then it's up to us to process it in our sync task. So again, we're doing an insert, update, and delete. We're defining the process here, and it's ultimately up to the trigger to provide us those data. And everything is working. They're all working together to make sure the data is passed into Oracle Postgres sync, and then eventually passes over to Postgres. So just a quick recap. So we pretty much accomplished the whole live sync workflow. Okay, and then just to wrap this all up, So if you followed along, you now have a solid base for real-time Oracle to Postgres syncing using Python as well as Oracle Advanced Q. Um, Thank you for watching. Hit like and subscribe for more coding walkthroughs like this. If you have any questions, feel free to add comments. I'll try to get back to you. Yeah. So thank you. Hopefully this helps you out. Thank you for watching. Appreciate it.